Welcome back to chapter 28, amines, section number 2, the properties of amines as bases. By the end of this video, you will be able to explain why amines behave as Bronsted-Lowry bases and explain why the base strengths of amines differ from each other and from ammonia. Let's examine the first idea, which is amines as bases. Before we go inside this idea, we will remember something. We know that a Bronsted-Lowry acid is an acid that has the ability to donate a proton. So a Bronsted-Lowry acid is a proton donor, H+ ion donor. However, Bronsted-Lowry bases, they do the opposite. They are proton acceptor, so they accept H+ ions. And amines, as we have seen in the previous section, amines can accept a proton, like you see here in phenylamine. The lone pair found on the nitrogen of the phenylamine, it attracts the proton of the acid. So whenever an amine is accepting a proton, we can call it a Bronsted-Lowry base. So amines can act as Bronsted-Lowry bases. The phenylamine here, when it accepts a proton, it will become a phenylammonium chloride, which is a salt. It is a cation connected to an anion. They form an ionic salt, which is soluble in water. Since we have said that amines can act as Bronsted-Lowry bases, so they can do reactions. So if I put an amine with an acid, they will react to produce a salt. Amines will react as Bronsted-Lowry bases in this case, and acids will be donating a proton in order for the amine to produce a salt. Let's take a real example. If I have ethylamine and I allow it to react with an acid, which is H+ and Cl-, H+ with Cl-, they form the acid HCl, which is hydrochloric acid. Together, if they react, what will happen? The lone pair found on the nitrogen of ethylamine will attract the proton of the acid. So it will become C2H5 and H3+, because it gained that proton, and plus Cl-. These together, the C2H5 and H3+ with the Cl-, they form an ionic salt we call ethylammonium chloride. Let's take phenylamine. How the phenylamine will react with the acid? Well, it will accept a proton and it will become phenylammonium chloride, which is the ionic salt. What will happen to this phenylammonium chloride salt? What will happen to it? Will it stay like that in the solution, or can I do anything with it? Can I use it? Of course, yes. If you put this salt again with excess amount of a base like HO-, the base will take back the gained proton and it will retain back the phenylamine primary amine. It will return it back as it was.